On April 20, 2025, NASA's Lucy spacecraft successfully captured groundbreaking images of the asteroid Donaldjohanson during its second close encounter with an extraterrestrial body. This remarkable event occurred approximately 600 miles (960 kilometers) from the asteroid, which is believed to have formed around 150 million years ago. The images obtained by the Lucy Long-Range Reconnaissance Imager LORRI reveal a complex and elongated structure that has intrigued scientists and opened new avenues for research into the early solar system. The Lucy spacecraft, part of NASA's ambitious mission to explore the Trojan asteroids, began transmitting its findings shortly after the flyby. Preliminary observations suggest that Donaldjohanson, with dimensions of around 5 miles 8 kilometers in length and 2 miles 3.5 kilometers at its widest, is larger than initially estimated. The spacecraft's close proximity allowed it to collect high-resolution images. Although the entire asteroid could not be captured in a single shot due to its size exceeding the imager's field of view. Hal Levison, principal investigator for the Lucy mission at the Southwest Research Institute, expressed his excitement about the results. Asteroid Donaldjohanson has strikingly complicated geology. As we study the complex structures in detail, they will reveal important information about the building blocks and collisional processes that formed the planets in our solar system. The unique shape of Donaldjohanson, likened to two nested ice cream cones, has confirmed prior expectations regarding its composition, hinting at a complex history of collisions and formations. The Lucy spacecraft's mission is not only about these flybys, it serves as a critical test for future observations of the Trojan asteroids, which are considered remnants from the early solar system. Tom Statler, program scientist for the Lucy mission at NASA headquarters, noted the significance of these early images, stating the potential to really open a new window into the history of our solar system when Lucy gets to the Trojan asteroids is immense. As the spacecraft continues its journey through the main asteroid belt, it is set to encounter its first primary target, the Jupiter Trojan asteroid Eurybates, in August 2027. This extended mission will allow scientists to gather more data, further enhancing our understanding of the solar system's formation and evolution. In a parallel development within the realm of space exploration, SpaceX successfully launched its 32nd resupply mission for NASA to the International Space Station (ISS) on April 21, 2025. The uncrewed cargo Dragon, carrying 6,700 pounds (3,000 kilograms) of supplies and scientific experiments, lifted off from Cape Canaveral, Florida. This mission was particularly crucial as it followed a transportation mishap that delayed another U.S. cargo mission. The launch comes amid ongoing challenges for resupplying the ISS, particularly with delays of the Northrop Grumman Cygnus NG-22 mission due to damage during transport. NASA had to adjust the CRS-32 mission's cargo manifest to include additional food and supplies for the ISS crew. Jennifer Buchley, NASA's ISS program chief scientist, explained, "We did have to reshuffle a bit of the manifest to make room for some more food and resupplies for the crew. However, we were able to optimize our cargo on this flight and add some more investigations back in." The upcoming Cargo Dragon missions will not only continue to support the ISS but will also test technologies for future deorbit operations of the ISS as it approaches the end of its operational life around 2031. Sarah Walker, SpaceX's director of Dragon mission management, emphasized the importance of these technologies, stating that the upcoming missions will serve as a supplemental capability to the ISS. As NASA and SpaceX move forward with their respective missions, the landscape of space exploration is evolving rapidly. The data from Lucy's asteroid encounters and the ongoing resupply missions to the ISS will contribute significantly to our understanding of space and its many mysteries. With each launch and encounter, scientists and engineers take another step closer to unraveling the complexities of our solar system, paving the way for future discoveries. As we look ahead, the potential for new breakthroughs remains vast, underscoring the importance of continued investment and innovation in space exploration. In a remarkable demonstration of international collaboration and scientific advancement, the SpaceX Falcon 9 rocket successfully launched its 32nd Dragon cargo mission to the International Space Station (ISS) early Monday morning, April 21, 2025. At 4:15 a.m. Eastern Daylight Time from NASA's Kennedy Space Center in Florida. This mission, designated CRS-32, carries a significant payload of approximately 6,700 pounds of essential supplies and groundbreaking scientific experiments, underscoring the vital role that commercial partnerships play in sustaining human presence in low Earth orbit. As the Dragon spacecraft embarked on its journey, astronauts aboard the ISS, including NASA's Johnny Kim and Japan's Takuya Onishi, prepared for its arrival. The Dragon is set to dock with the station's Harmony module at around 8:20 a.m. Eastern Daylight Time on April 22, where it will deliver a variety of cargo, including food research materials and innovative scientific experiments. Kim and Onishi, responsible for monitoring the docking process, have been actively reviewing procedures and preparing for a series of upcoming tasks, including a spacewalk scheduled for May 1. The CRS-32 mission comes at a critical juncture for the ISS program, particularly following delays with other resupply missions, including Northrop Grumman's Cygnus NG-22, which was sidelined due to damage during transport. Jennifer Buchley, NASA's ISS program chief scientist, noted in a pre-launch briefing that adjustments had to be made to the Dragon's cargo manifest to accommodate additional food and supplies for the crew. "We did have to reshuffle a bit of the manifest to make room for some more food and resupplies for the crew," she stated, highlighting the adaptive nature of space logistics. Among the scientific payloads aboard this mission is the Solar Flare X-ray Timing Investigation (SFXTI) developed at Montana State University. This instrument aims to measure high-energy X-rays from solar flares, providing vital data that could enhance our understanding of solar phenomena and their potential impact on Earth. NASA asked for proposals through the EPSCOR program for investigations utilizing the ISS. "We responded proposing a device that would measure hard X-rays prompted by a desire to understand how X-rays are being created in solar flares," explained Dave Klumper, a former MSU research professor involved in the project. The successful launch of CRS-32 also reflects advancements in SpaceX's capabilities. The Falcon 9's first stage booster, B-1092, executed a flawless landing at Cape Canaveral Space Force Station after its third flight. This marked the 51st successful landing at Landing Zone 1 and exemplifies SpaceX's commitment to reusability and cost efficiency in space travel. Sarah Walker, SpaceX's Director of Dragon Mission Management, emphasized the importance of continuous improvement, stating access to such a huge volume of flight data and the spirit for constantly making things better allows us to refine Dragon into the best possible spacecraft for the missions that it executes. As the Dragon spacecraft awaits its docking and the crew prepares for the upcoming spacewalk, the implications of this mission extend far beyond immediate resupply needs. With more than 30 new experiments en route, including studies on air quality and protein behavior, the mission promises to yield insights that could have profound effects on both space exploration and terrestrial applications. The collaboration between NASA, SpaceX, and international partners like JAXA exemplifies a shared commitment to pushing the boundaries of human knowledge and capability in space. As we look ahead, the ISS will continue to serve as a platform for scientific discovery while preparing for future missions that may one day take humanity beyond low Earth orbit. The next Dragon cargo mission, CRS-33, is anticipated to launch this summer, further enhancing the ongoing cycle of research and resupply essential to maintaining operations aboard the ISS. With upcoming advancements like the introduction of Sierra Space's Dream Chaser and Boeing's Starliner, the landscape of commercial spaceflight is poised for significant evolution, promising exciting developments in the years to come. On a momentous day that marked both his 70th birthday and the culmination of an extensive 220-day mission aboard the International Space Station ISS, NASA astronaut Don Pettit returned to Earth in a Soyuz capsule on April 21, 2025. This remarkable journey has not only set a personal milestone for Pettit but also underscores the evolving narrative of age and capability within the realm of space exploration. As Pettit, along with Russian cosmonauts Alexei Ovchinin and Ivan Vanner, made their descent toward Kazakhstan, they had collectively circled the Earth 3 520 times and traveled a staggering 150.2 million kilometers, 93.3 million miles since their arrival at the ISS in September 2024. NASA celebrated Pettit's contributions during this mission, highlighting his work on enhancing metal 3D printing capabilities, advancing water sanitization technologies, and conducting experiments in microgravity that could pave the way for future space endeavors. He also used his surroundings aboard the station to conduct unique experiments in his spare time and captivate the public with his photography, NASA noted. The media spotlight has largely been drawn to Pettit's age, as he now holds the title of NASA's oldest living astronaut. However, while he may be the oldest currently active, the record for the oldest astronaut in history belongs to John Glenn, who flew at the age of 77. Notably, the title for the oldest person to fly in space is held by actor William Shatner, who ventured above the Kármán line aboard Blue Origin's first crewed flight in 2021. With age often seen as a barrier in high-stakes environments like space missions, Pettit's return raises questions about the selection criteria for astronauts. NASA emphasizes that there are no upper age limits for its astronaut candidates, although candidates must pass rigorous physical examinations which can become increasingly challenging with age. In contrast, the European Space Agency (ESA) has a more stringent cutoff, requiring candidates to be under 50 years old at the time of application due to the physical demands of the role. Pettit's journey back to Earth was not merely a return from space, it was a celebration of perseverance and human spirit. Upon landing, he underwent health checks and was reported to be doing well. His successful mission and subsequent return at an age where many are contemplating retirement serve as a powerful testament to the capabilities of older astronauts in an era where experience can be as valuable as youth. Looking ahead, Pettit's achievements and the data gathered during his mission will undoubtedly contribute to future space exploration efforts, including potential missions to Mars and beyond. As the conversation around age and capability in high-risk fields continues, Pettit stands as an inspiring figure, reminding us that passion for exploration knows no age limit. The future of space travel, enriched by seasoned veterans like Pettit, promises to be as exciting as it is transformative. This Earth Day, NASA is taking the opportunity to highlight its significant contributions to understanding and preserving our planet through innovative satellite technology and extensive scientific research. The agency's 2025 Earth Day poster, featuring stunning imagery from the Landsat mission, a joint collaboration with the U.S. Geological Survey, serves as a visual reminder of the intricate dynamics of Earth as seen from space. Reflecting on over 6 decades of Earth observation, NASA has provided the world with remarkable insights, extending from the spectacular views captured by the Apollo missions to the sophisticated data collected by contemporary satellites like the Plankton Aerosol Cloud Ocean Ecosystem PACE. NASA science delivers every second of every day for the benefit of all, and it begins with how we observe our home planet from the unique vantage point of space, stated Nikki Fox, Associate Administrator for the Science Mission Directorate at NASA. This perspective has proven invaluable, yielding data that informs agricultural practices, air quality monitoring, and atmospheric studies, ultimately enhancing our understanding of the environment and its myriad complexities. As agriculture increasingly relies on precise data, NASA's contributions are pivotal. Farmers across the U.S. benefit from continuous measurements of water availability and crop health, allowing for informed decision-making that resonates from local farms to global markets. This data informs field-level farming and ranching decisions with an impact felt as far as the commodity trading floor in our grocery stores, explained Karen St. Germain, Director of NASA's Earth Science Division. Looking ahead, NASA's commitment to advancing Earth observation continues with the highly anticipated launch of the NASA ISRO Synthetic Aperture Radar (NISR) mission, set for later this year. This collaborative effort with the Indian Space Research Organisation aims to monitor land changes induced by natural disasters such as earthquakes, landslides, and volcanic activity. Equipped with radar capable of detecting shifts as subtle as 0.4 inches over expansive areas, NISR will enhance our disaster response capabilities, offering critical data that can improve preparedness and mitigation strategies. The agency's broader mission encompasses monitoring various environmental changes from the health of ocean ecosystems to the stability of ice sheets that influence global sea levels. With each observation, NASA not only celebrates the beauty of our planet but also underscores the importance of safeguarding it for future generations. As we commemorate Earth Day, NASA's ongoing efforts serve as a reminder of our collective responsibility towards the Earth. The challenge ahead is to leverage this wealth of scientific data to foster sustainable practices that protect our home. Future missions and technologies promise to deepen our understanding, ensuring that humanity can thrive in harmony with the planet's ecosystems. For those interested, NASA has made the 2025 Earth Day poster available for download, inviting everyone to engage with the beauty and fragility of our shared world. In a significant stride for planetary science, NASA's Curiosity rover has unveiled compelling evidence that Mars may have once harbored conditions conducive to life. This discovery comes as Curiosity meticulously climbs the slopes of Mount Sharp located within Gale Crater, where it has identified large deposits of iron-rich carbonates, minerals that offer critical insights into the planet's ancient climate history. The findings, published on April 21, 2025, reveal that these carbonates likely formed in an environment characterized by the interaction of carbon dioxide with water and rock, followed by evaporation. This process suggests that Mars once had a more substantial atmosphere rich in carbon dioxide, enabling liquid water to exist on its surface. It tells us that the planet was habitable and that the models for habitability are correct, stated Ben Titolo, the study's lead author and an associate professor at the University of Calgary. Curiosity's analysis points to a dynamic past where carbonates formed under extremely dry conditions, indicating a period when Mars could sustain life. Among the notable minerals discovered is siderite, an iron-rich carbonate found in significant quantities alongside salts that are readily soluble in water. Titolo elaborated, the broader implications are that the planet was habitable up until this time, but then as the carbon dioxide that had been warming the planet started to precipitate as siderite, it likely impacted Mars' ability to stay warm. The implications of these findings extend beyond Mars, as they intersect with ongoing research on Earth. Titolo highlighted that the natural processes observed on Mars could inform current efforts to combat climate change through the stabilization of carbon dioxide in carbonate minerals. Learning about the mechanisms of making these minerals on Mars helps us to better understand how we can do it here, he remarked. In tandem with Curiosity's discoveries, research into Jezero Crater, the landing site of NASA's Perseverance rover, has further illuminated Mars' geological history. A recent study co-authored by Dr. Michael Tice from Texas A&M University revealed the presence of diverse iron-rich volcanic rocks in the crater. These findings suggest prolonged volcanic activity on Mars, which may have provided a sustainable environment conducive to the development of life. Utilizing advanced technologies aboard Perseverance, researchers have been able to analyze Martian rocks with unprecedented precision. Tice noted, "We're not just looking at pictures, we're getting detailed chemical data, mineral compositions, and even microscopic textures. It's like having a mobile lab on another planet." The study's findings indicate a complex volcanic history characterized by various lava flows, which could have contributed to a more hospitable environment for life in Mars' early history. The analysis of these volcanic rocks indicates that they underwent significant alteration processes, including fractional crystallization and crustal assimilation. Tice emphasized the importance of this work, stating, "If Mars had an active volcanic system for an extended period, it might have also maintained conditions suitable for life for long portions of Mars' early history." Both Curiosity and Perseverance are set to play critical roles in the Mars sample return mission, a collaborative initiative between NASA and the European Space Agency aimed at returning Martian samples to Earth within the next decade. Dr. Tice expressed optimism about forthcoming discoveries, asserting some of the most exciting work is still ahead of us. This study is just the beginning. As we continue to explore the mysteries of Mars, these discoveries not only enhance our understanding of the planet's potential for habitability but also provide valuable lessons for addressing challenges on Earth. With ongoing advancements in technology and science, the story of Mars is far from complete, and the coming years promise to deepen our grasp of its geological history and the potential for ancient life. In a significant leap forward for lunar exploration, NASA has officially cleared the Lunar Environment Monitoring Station (LEMS) for construction, a critical component of the upcoming Artemis 3 mission. This compact suite of seismometers, about the size of a carry-on suitcase, aims to provide continuous monitoring of the Moon's surface for ground movement caused by moonquakes. As NASA's Public Affairs Officer Molly Wasser emphasized, the data from LEMS will help scientists better understand the Moon's internal structure and evaluate the seismic hazards for human exploration. Scheduled for deployment by astronauts during the Artemis 3 mission, the LEMS will be instrumental in recording seismic activity on the lunar surface, which is influenced by both meteoroid impacts and the Moon's gradual cooling and contraction. Tests conducted in September 2024 at the Florida Space Institute's Exolith lab demonstrated the instrument's capabilities in a simulated lunar environment, paving the way for its future deployment. The data collected will be crucial for understanding the Moon's geological processes and ensuring the safety of future missions. In a related effort to enhance lunar exploration, DARPA has issued a solicitation for proposals for a small lunar orbiter named the Lunar Assay via small satellite orbiter LASSO. This mission is designed to prospect for water ice on the Moon while testing navigation and propulsion technologies necessary for operating in the Moon's challenging low-orbit environment. By mapping the lunar surface for water ice concentrations which are vital for sustaining human presence on the Moon, LASSO aims to identify regions with at least 5% subsurface water ice. The necessity for such a mission is underscored by the challenges NASA has faced with its own lunar water searching initiatives, including the troubled Lunar Trailblazer mission. With LASSO, DARPA hopes to advance both military and commercial capabilities in cislunar space, as the solicitation notes. Sustained and advanced maneuverability for spacecraft is key to enabling further improvements of SSA in cislunar space. These initiatives align with a broader vision of establishing a sustainable lunar economy, as highlighted by DARPA's 10-year Lunar Architecture project announced last year. This project aims to explore the necessary infrastructure for lunar activities, including power and transportation systems essential for supporting mining operations and other commercial endeavors on the Moon. As NASA and DARPA move forward with these ambitious plans, the implications for both scientific discovery and human exploration are profound. The data gathered from the LEMS will augment our understanding of the Moon's geology, while LASSO's search for water ice could pave the way for longer-term human habitation. Both efforts represent crucial steps toward a future where the Moon serves not just as a destination, but as a hub for further exploration of the solar system. As we look ahead, the collaborative efforts between NASA, DARPA, and private sector partners will likely yield exciting developments in lunar exploration and technology, setting the stage for a new era of discovery and human presence beyond Earth.